I have to convert it into 1 meter. So SI system, basically it's a standard system, and this governs the units and dimensions. So in our SI system, we have 7 fundamental quantities, and these quantities are listed and they are fixed. They are permanent. With these, we have 2 supplementary quantities. Fundamental and 2 supplementary quantities. Now let us look what are these 7 fundamental quantities. And in our dimensional analysis, dimensional formula, we will be utilizing these. Aisha, is it audible? Aisha Sultana?
Yes.
Okay. So see, how do we represent this? We represent the mass with capital M. SI unit of mass is kg and CGS unit of mass is grams. Length is represented as length. SI unit is meter and CGS unit is centimeter. Now class, what is the CGS? I've been talking about this term. CGS. C means centimeter, G means grams, and S means seconds. Okay, CGS unit, centimeter, grams, seconds. So in this, there, see, one system is that is applicable is the SI system. One system a little lesser than it is also acceptable, which is the CGS unit. So you need to answer everything in terms of SI only. Your answers of SI unit are valid. Just in case if you have some questions where you have to perform the conversion, then you can use the CGS unit. So you should be aware of it, at least for few quantities. Next, you have time. Time is represented by capital E, and it is in seconds in both of it. Time in your CGS and SI. Then you have temperature, which is represented as either as theta or Kelvin. So why Kelvin? See, in some books you will find this as theta. Most of the books have theta only. But some books you will find this written as K also. K basically stands for Kelvin. That's why this is written. And CGS is degree Celsius. Class, till here, till this table, you need to know the SI also, you need to know the CGS also. Both SI and CGS should be remembered by you. And how you represent it. The rest of the 3 which are present, which are left here, the rest of the 3, electric current, luminous intensity, amount of substance. See, electric current will come in your class 12th. That time you have a little detail of electric current. So electric current is represented by the symbol A. Okay. This is how you represent current. It's a fundamental quantity. And why A? Because the unit of current is ampere. Yes, ampere. Right. And luminous intensity. Class, luminous intensity means suppose the light is on right now. Luminous means the amount of light that is coming. Luminosity means light. Intensity means how much stronger is the light. Is the light strong? Is it weak? Is it dim? Or it's overshooted? So luminous intensity is that. SI unit, I'll just discuss. This is candela. Okay, SI unit is candela. Again, I have seen these 3 are not very important for you. For your class 11, first 4 are very important. Third can be used sometimes in some of the questions. Then you have amount of substance. Amount of substance you will do in detail in your molar concept of first chapter of chemistry. Right, so you have the full detail of number of moles and chapters and all. So amount of substance is given by. Is this table clear to both of you, Aisha and Fatma?
Yes. Yes, ma'am.
Okay. So please start writing from here. Just text me done in the chat box. Then I'll discuss those 2 supplementary quantities after that.
Okay.
Okay, let's continue forward. Fatma, you've also completed?
Yes, ma'am.
Okay. So see the supplementary quantities. So see some things are there that are already listed and we have to study. So supplementary quantities, one is the plane angle. See plane angle means the angle that is formed in 2 dimensions, which you have been using till class 10th also you have used it. What was the angle? Sine theta, cos theta, what was it? It was a plane angle. Means the angle which is formed by intersection of 2 lines like theta. This is represented by theta. So see, this is represented by theta and the SI unit. So are you aware of the SI unit of angle? Anyone? Radian class, okay? This is radian, written as RAD. This is the radian. Next you have solid angle. Solid angle means an angle that is formed in 3 dimensions. Means if I have this and I convert it into a cone. So when I convert this piece of paper into a cone, see, this is how it will appear, right? So this part, this inside part of it, this which is available, the tip, this is actually the angle of the cone only. So this part which is visible, this is the solid angle. Means angle that is formed in 3 dimensions, the 3D angle. So this is 3D. Like the best example is you take the example of a cone. This part, this is the solid angle. That is the example of a cone. So this is represented by this symbol. This is called as omega. This symbol is called as omega. And the SI unit represent
Steradian.
is how much?
Steradian.
Yes, correct. The SI unit of a solid angle is just at CSTE to the radian. This is steradian, right? Okay, now coming to the derived quantities. Derived means, see, any new quantity that is formed is called a derived quantity. Like you have so many examples. If I talk about velocity, it is position divided by time. I talk about force, this is mass into acceleration. I talk about anything acceleration, it is velocity by time. Anything which is formed new is the derived physical quantity. Okay, now this is just the introductory part of the chapter. Now we'll come properly to how to write the dimensional formula and everything. Okay, class. So write it till here, then I'll discuss.
Ma'am, after plane angle, you have written 2 dimensions.
Yes, Fatma?
After plane angle,
Yeah, after plane angle?
it is 2 dimensions, 2D.
Yeah, 2D. See, you are drawing it on a sheet.
Yes.
1D 1D means a straight line, but here you require it to draw on a sheet of paper. That is 2 dimensional drawing. Solid
Oh,
angle is a 3 dimensional, 3D figure that is present.
okay. Done, ma'am. Done, ma'am.
All right, both of you have completed?
Yes, ma'am.
Okay. Now, class, we'll actually start with what is the dimensional formula that is present. Okay, the how we really write this dimensional formula. So, see, everything that you have to write will be of the structure MLT. Okay, for writing the dimensional formula, you should have with you the skeleton structure that is present is MLT like this. And then you write the powers to the power X, to the power Y, to the power Z. Now, what is this mass? This is M is the mass, L is the length, while T is the time. So you have to, what you have to do, you have to write everything in terms of this. This would act like your skeleton structure, and this you will be acting, putting everything in terms of this. Like area is length into breadth. So for length, see lengths from the table of fundamental quantities, you have length as L. And breadth. Breadth is also a distance only, measurement of length only. So this can be written as L. So see, L into L, that becomes L square. So how do we write the dimensional formula? Writing of dimensional formula. See, you can write it like this also, L square, or you can write this as M0 L2 T to the power 0, like this. This is how you construct. Let's see one more example. Let's see volume. See, volume's formula is length into breadth into height. Length can be written as L, breadth can be written as L, and height can be written as L. So dimensional formula becomes L cube. Let's take one more example. Density. Density's formula is mass by volume. Now mass is M. Volume is L cube. Just now we have seen what's the volume's dimensions? L cube. So see, when this L will go up, the signs will change. So M L to the power minus 3. You can write like this also, or you can write this as M L to the power minus 3 T to the power 0. Got it, class?
Yes. Yes, ma'am.
Okay, so basically, see, in the first chapter, don't focus on writing the formula. What is the formula? What is the meaning of it? No. Your task should be to how to manage with the dimensional form. Okay, just write the dimensional formula, that's it. So write it till here, then we'll discuss some good quantities that are present in your syllabus. Start writing and keep on texting me done in the chat box, so I'll scroll it. All right, class. So see, you have a list of certain quantities. Let us start with some quantities today. First is distance or displacement. Now, I'll tell you again this thing. Don't focus on writing the actual formula of the content or understanding what is the meaning of distance or displacement or any physical quantity. See, class, you have every chapters on these physical quantities. Distance, displacement, speed, velocity, all these things will be covered in your respective chapters, right? So don't focus on this. What you need to focus is that if you have the formula, if you have the final formula, then you should be able to write the dimensions. So if you have length, dimensional formula will simply be capital L. SI unit is meter, CGS unit is centimeter. Then you have velocity. Look, velocity is distance divided by time. Distance or displacement by time. Basically, speed is distance by time, velocity is displacement by time. What are they? What are the meanings of these? These we'll study in the chapters. Now look, distance is L, time is T. So this becomes LT to the power minus 1. So this will become meter per second or centimeter per second. Then you have acceleration. Acceleration is what? It is velocity by time. Means if velocity is LT to the power minus 1 divided by time. Now look, when this t will go up, it will become minus 1. L t to the power minus 1 means minus 2. Because even bases are same, the powers are added up. So when this t goes up, it will become t to the power minus 1. See, this is like this, no? L t to the power minus 1. And then you are getting t to the power minus 1 again. So bases are the same, look. So powers get added up. So minus 1 is minus 2. And the unit is meter per second square or centimeter per second square. Got it, class, till the 3?
Yes. Yes, ma'am.
Okay, make a proper table for this because these things are asked in the exam. Okay, write it and just text me done. Okay, class, let's move forward. Now see, there's a quantity momentum. Momentum basically means amount of motion. Amount of motion in a body. Like if you are moving in, or if let's take an example, you are running. Okay. So when you want to stop, do you just immediately stop like this? No. Because your body has gained so much momentum, there is so much amount of motion in your body that you tend to travel a bit and then you stop. So mass is m, velocity is L t to the power minus 1, right? So when you multiply them, you get m L t to the power minus 1. Just a second. Wait. This was hanging. I'm just resharing it. Just wait. So basically, see, when you have mass into velocity, mass is dimensional formula you already know. Velocity is dimensional formula we have calculated from the above part. So when you are calculating the dimensional formula for momentum, it is mass multiplied to velocity. That is mlt to the power minus 1, like this. Now class, SI unit also has to be written like this. If mass is kg, we'll write kg. Velocity is meter per second. So this is our CGS unit. Gram centimeter per second is the CGS unit. Sorry, this is the SI unit. This is the CGS unit. This is how you run. Now see, mass is m. Yes, Fatima, can you tell me what is acceleration's dimensional formula? You must have written it.
LT raised to minus 2.
Yes, LT to the power minus 2. So look, if you have LT to the power minus 2, just a second. So if you have LT to the power minus 2, then see, you multiply mass with that. So total formula will be mLT to the power minus 2. Individually, I'll suggest you class that distance, displacement, velocity and acceleration. You remember it. If you remember these acceleration, velocity and all, it will be beneficial for you. Let me share the screen for you. Let me know once the screen is visible.
Ma'am, which all formulas can you repeat?
What, Fatima?
Ma'am, you were saying, right, some formulas if we learn that, then it will be
Yeah. See, I'll tell you. Let us complete this table, or I'll just tell you in this. If you remember some of it, just 5 of it, that will make your calculation, not calculation exactly, but writing of the dimensions very easy. See, displacement and distance are very easy. They are just length. You can remember. Remember velocity. It will be used in most of the things. Remember acceleration. No need to remember momentum. Remember force. Remember work done. These 5.
Oh.
Remember these as it is. So yes, mass into acceleration we were discussing. Huh?
Yes.
So this is m into LT to the power minus 2, that is MLT to the power minus 2. Class, if you remember these will be very helpful. SI unit is Newton, CGS unit is 9. We'll see some pair of questions. I think not today, time is not there. Whenever we have our next class, your timings and all will be changed. Right now, because see, already it's April end, that's why we had to start with the class. Your timings will be discussed. Just give your preferable timings and all. So when you will do the questions, that time you will see that yes, some of it are being repeated and they are used everywhere, like velocity, force. These are used a lot. And this work done, class, remember this work done's dimensional formula. Why? This is force. Force is mlt to the power minus 2. Displacement is L. So this becomes ml square t to the power minus 2. Why am I saying on work done? Class, work done, whatever is the dimensions of work done, is the exact dimension of all the sorts of energies that are present. Kinetic energy, potential energy, internal energy. You take any energy of the world, dimensions will be this. So by remembering work done's formula, you are actually remembering all the energies that are present. So remember 5 of these will be very helpful. This is joules, CGS unit is erg. So Aisha, can you now tell me, see pressure is force by area. What is force? Dimensions? See on the screen?
Force is mlt raised to the power minus 2.
Yes. Divided by, what is areas? Yeah, Aisha? Area we did as the first example. Check the notes. You must have written the first example that we did.
Yeah, L square.
Yes, L square. So look here. This L will cancel one of the length. We will be left with M. See, this is L in the denominator. When it will go up, it will become -1. T to the power -2. Pressures is Newton per meter or meter square, or you have one more unit, that is Pascal for pressure, represented as PA. See, CGS unit will be dyne per centimeter square. So see, this is the note point which I was referring. Work done in types of energies have the same dimensional formula, ml square T to the power -2. So class, out of this table, work done, force, acceleration, speed, and distance, they are of your prime importance. Okay, please start writing from here.
Now, what's the SI unit of momentum?
SI unit for
Momentum.
momentum. Oh, sorry, I didn't write. This is kg meter per second. And this will be gram centimeter per second.
Ma'am, what does ERG mean?
Yes, Fatma?
Ma'am, the CGS unit for work done ERG, what does that mean?
ERG. This is just the name of the CGS unit. Like, see, you're not familiar with it. That's why this is sounding something new. Like grams. You're familiar with grams. kg is the SI and CGS is gram. Similarly, joules is the energy or work done's SI unit and CGS is ERG. We'll see in this chapter only how to convert and what is one ERG equal to or one joule equal to.
Okay.
Done, ma'am.
Okay, class, let's practice one question. See, in the next class, we'll practice one more question and then we'll have some more quantities. We have a list of quantities that you need to know and they are available in your NCRT, so it can come in the exam. See, the question says F is force is G m1 m2 by r square and we have to calculate the dimensional formula for capital G. Now, again, I'm telling you, don't go into the details. In chapter 8, you have a chapter gravitation. In gravitation, you will see all the details of it. Right now, just focus on finding the value of this capital G. So see, F is the force, M is the mass, M1 and M2 are masses, R is the separation. Separation means the radius. So forces dimension is ML or C, wait. Because you have questions like this. F is equal to G M1 M2 by R square. So from here I can say capital G will be equal to F into R square by M1 into M2, right? Cross multiplication. So capital G will be, see, force we have written. That's why I'm saying if you have these things, see, all these things are from fundamental. Question is very easy. F is mlt to the power minus 2. Radius, see, length is L. So radius square will become
L
L.
square.
For first mass, we have dimensional formula as M, M2. It is also a mass, so it will be M. So look, how can we solve this? One mass will be cancelled. Now when this mass will go up, everything should be in the numerator. So M to the power minus 1, L into L square becomes L cube, T to the power minus 2. Clear?
Yes.
Fatma, to you?
Yes, ma'am.
Okay. Just write down this question, please.